So I'm excited to be sharing some of our findings on the public's prior knowledge about the causes of autism and some of their beliefs about treatments. What I'm presenting today largely will be new data, so we're excited to get your questions and feedback on it. So with this presentation, I have two objectives. My first one is to present international evidence on people's prior knowledge about the causes of autism, ASD, what I'm referring to as the global incidence. And secondly, relations between people's prior conceptions and what ASD treatments people will accept, and particularly what ASD treatments they will recommend to a friend or a colleague. So in addressing the first aspect, the global incidence of these conceptions, we collected data from 3 sites here in Minnesota at last year's state fair, across the US, online via Amazon's Mechanical Turks, and in collaboration with our colleagues in Spain at the University of Valencia, for a total of 760 participants. And to measure what people thought were causes of ASD, we presented all participants with the Illness Perception Questionnaire, an adaptive version of this in their native language. So participants were presented with this question: which of the following do you believe are factors that cause autism? Select all that apply, and also rate your confidence in each of your responses. And this was followed by an inventory of 19 risk factors that was intended to represent lay beliefs about ASD etiology. So you'll see some evidence-based risk factors like genes, and then some unsupported risk factors like God's will or vaccinations. And the analysis I'll show you next is the proportion of people who said yes, I believe this to be a factor that causes autism. And to make that more interpretable, I'm going to present that as a heat map format. So, for example, about 9% of our sample in Minnesota believe that a germ or virus causes autism, 16% in our general USA sample, and 14% in our Spanish sample. And chi-square analysis showed that there was a significant difference between the USA sample and the Minnesota sample. It was also relatively low for people who believed an accident or injury causes autism, but that was equal across samples. It was a little bit higher for alcohol, smoking, or drug use during pregnancy. It was also equal. So red colors indicate, I'm not sure if that color shows up in here, but the redder color is indicating a low percentage of people saying, yes, I believe this to be a factor, and blue is a higher proportion of people saying, yes, I believe this to be a factor. So here are the rest. And I can share this afterwards with anyone who is interested, but I'll just quickly walk through some of the salient findings here and highlight them. So in terms of brain abnormalities, nearly a unanimous number of our samples said, yes, I believe this to be a risk factor, ranging from 82% to 90% of people saying, yes, this is a risk factor. But if you look right below it in chemical imbalance, about 3/4 of our American samples said, yes, I think this is a risk factor, but less than half of our Spanish samples said the same thing. And that difference was significant. And if you look a little bit lower at genes, well, again, it was roughly unanimous in terms of, is that going down? Okay, roughly unanimous in terms of like how many people saying yes, but below that in terms of vaccinations, roughly 1/5 of our sample saying yes, I think this is a risk factor too. And I haven't completed a systematic review of the literature yet, but so far these are the highest numbers I've been seeing for this type of misconception. Before, I've been seeing 5 to 10% of people saying this was a risk factor, so it being this high is interesting. And if you look within samples, you'll see that some people are saying that genes are a risk factor, and there's probably a subset of those people are also saying that vaccines are a risk factor at the same time. So distill some of these findings and define the defining sample characteristics. I looked at the differences between the samples and the magnitude of those differences, and this is what we found. In the American samples, the Minnesota and US combined, more than the Spanish samples, they believe that a chemical imbalance, toxins, and environmental exposure were risk factors. And so I grouped that into a higher thematic category of teratogens. And American samples, more than the Spanish samples, also believe that a nutritional deficiency of the child and nutritional issues during pregnancy were also risk factors, which I labeled as a diet. And they also believe that allergies, Americans more than Spanish, believe that allergies were a risk factor, which might reflect in some kind of autoimmune hypothesis as a cause. And in contrast, the Spanish participants, more than the American participants, believe that mental illness and illness during pregnancy were causes. And I wasn't sure if or how to group those together, so it's tentatively titled other disease. And last, Spanish participants, more than American participants, believe that stress, family problems, and parenting were causes. And so I grouped those together as negative home environment. So these are new findings for us, and we still need to review the literature to find out how to better interpret them and their potential significance. But we were also interested in seeing what impact these conceptions would have on the immediate interactions people have with one another, like whether or not they would recommend a practice or whether or not they would accept a practice. So in our second objective, focusing on the local influence of these conceptions might have between treatment options, we focused in on our general US sample that was collected online via MTurks. And in addition to the illness perception questionnaire, we also presented 15 short texts on various ASD treatment options. Some of these texts were evidence-based, some of them were non-evidence-based, and some were control texts that we wrote ourselves. So, for example, in evidence-based practices, we have video modeling, social narratives. For non-evidence-based, we have pressure-weighted vests, gluten-free diets. And then we had a control text like virtual reality and brain training video games. We chose those ones, we wrote those ones because we wanted something that might seem plausible as an ASD treatment for someone who didn't know, but to our knowledge hadn't been publicized as such. So we did isolate the impact of like familiarity with ASD practices or treatments. So after reading each of these texts, we asked people 6 questions. How familiar you are with that practice, whether or not you understood what was being described, whether or not you found it credible and believable, whether or not you would accept that practice, and whether or not you would recommend it to a friend or colleague. So an example of that latter question looked like this. If applicable, I would use or recommend to a friend to use gluten casein-free diets as a practice for individuals with ASD, and that ranged from strongly disagree to strongly agree. And broadly, our hypothesis here was that people's recommendations would differ based on what they thought were causes of autism. So we took the illness perception questionnaire and we coded all the yes responses with a positive one and all the no responses as a negative one. And then we multiplied those 2 values by how confident they were, their confidence scores. So that ranged from 1, not at all confident, to 5, completely confident. And that gave us a sense of how confident people were in their yes or no responses, ranging from a -5, which is a completely confident no, this is not a cause, to a +5, which is a completely confident yes, I think this is a cause. And it was on these data we performed a cluster analysis trying to find subgroups within our sample that responded in similar fashions. And we did find 3 subgroups. And the first one gave completely confident yeses in genes, neurological disorders, and brain abnormalities as risk factors for ASD, and pretty confident no's in pretty much nearly everything else. So we'd labeled this group the neuro cause cluster. The second one gave pretty unconfident responses on nearly everything, and so we called this the uncertain cause cluster. And lastly, the last group gave relatively confident yeses on a number of factors, so we called this the multi-causal cluster. So we entered cluster membership, evidence-based condition as independent variables, and the 6 responses we got from people as the dependent variables in a repeated measures ANOVA, and this is what we were seeing with that. So, and how familiar each condition was, the top line, you can't it's the yellow line, it's tough to see, but that's the control text, and that was rated as the most familiar to people across the 3 clusters. And so as just a reminder, those conditions or those texts depicted virtual reality, brain training video games, so that was rated the most familiar. In terms of, we had the non-evidence-based practices as the second most familiar and the evidence-based practices the least familiar. So you can already see that we're dealing with a knowledge deficit right off the bat. On how understandable the texts were, clusters 1 and 3 were relatively equivalent in their self-reported comprehension, but cluster 2 self-reported a very low level of comprehension. So in addition to that knowledge deficit we just saw, for cluster 2 there was also a comprehension deficit. And where I think it gets interesting are on the next few. For how credible the text was, cluster 1 could successfully differentiate between the 3 types of texts, and in the order we'd hope that they do. So they rated evidence-based practices as the most credible, and the non-evidence-based practices as the least credible, and the control was somewhere in between. And that was the neuro cause cluster. For cluster 2, who was uncertain about the causes, could not successfully differentiate the credibility among these 3 types of texts, so they rated them all equally credible. And then for cluster 3, who believed in a multitude of factors causing ASD, they were somewhere in between these 2 groups. They could differentiate evidence-based practices from the non-evidence-based practices, but they could not differentiate between the evidence-based practices and the control texts. And that pattern held up for whether or not you believed the practice as a practice for ASD, whether or not you approved of the practice for ASD, and whether or not you would recommend that practice for individuals with ASD. So something about confident beliefs in a neuro basis in isolation by itself acted as a protective factor against accepting non-evidence-based practices for individuals with ASD. But once other beliefs are entered into that conceptual network, as we saw for cluster 3, who believed in a multitude of beliefs, or when there's no confidence across the board, as we saw for cluster 2, that protective factor disappears and people start to accept other forms of practices. So in sum, we first saw that beliefs about ASD causes differ between the US and Spanish samples, giving us a sense of some cross-cultural differences and the global incidence of misconceptions that may be the target for customizable interventions. And second, as we just discussed, such prior conceptions working in tandem within a conceptual network are linked to which ASD treatments people will accept, and that implicates the spread of pseudoscientific information between individuals in real life communities and in online communities. Thanks.